Hello, students. Hope you're all safe and healthy at your homes. So, let's revise the chapter electricity once as we have completed it in last video. The chapter electricity starts from electric current and electric potential difference and electric circuit. Okay, so first of all, what is electric current? We all have studied in our classes that in our lower classes that any conductor which conducts electricity like metals have free electrons to move, right? These free electrons when move in the conductor, then they constitute electric current. And how they move because they are experiencing some force to move from one place to another place. And what is this force? This force is provided by battery, that is a source of electric potential difference, right? That concept we have studied. And how will we define this electric current? According to that, it is nothing but amount of charge flowing through a particular area of a conductor in a unit time. With respect to time, if we consider how many charges are moving, okay, so that will give us the value of electric current, and it is represented by I. Capital I is the representation, we all know, right? Another way of defining this electric current I have written over here: the rate of flow of electric charges, that is electrons, negatively charged particles in any atom, is called electric current. Okay, now this is the formula, that I is equals to Q upon T. Q is what? Q is representing charge, this charge. And rate of flow, rate means with respect to time. With respect to time, how many charges are flowing, that is the formula. Okay, so Q is the amount of charge which is measured in coulomb, that is represented by capital C. Okay, coulomb is SI unit of charge. For time, the SI unit is seconds, that we all know. Okay, so the SI unit of current becomes coulomb per second. Okay, but it was given by Ampere, Andrew Mary Ampere, that the SI unit of electric current that we will consider is ampere. Okay, that is represented by capital A. Now how we will define this unit of electric current? That is defined by defining 1 ampere. 1 ampere. How much is 1 ampere? This we can easily remember using this formula: current, charge and time. Current is 1 ampere, okay, and charge is 1 coulomb and time is 1 second. So if 1 coulomb of charge is moving in a conductor in 1 second, it will constitute 1 ampere of current. This is how we can write: 1 ampere equals to 1 coulomb divided by 1 second. Okay, these are the two type of definitions that we can have. The current is said to be 1 ampere if 1 coulomb of charge flows through a conductor in 1 second. Or in other words, the meaning is similar. 1 ampere is that amount of current constituted by the flow of 1 coulomb of charge per second. Okay, now the smaller units of current that are given in your syllabus, in your books, are milliampere, small m, capital A is the representation, and microampere. Micro is the symbol for 10 raised to power 6 and capital A is the symbol for ampere. This is the symbol for micro. Micro means 10 raised to power 6 minus 6. Okay, so 1 milliampere, here we can see that is equal to 10 raised to power minus 3 ampere. If this is beneficial for your numerical purpose. Wherever it is given in microampere or milliampere, you can easily convert it into amperes SI unit. Okay, so 1 microampere is equals to 10 raised to power minus 6 amperes, right? Now next come, what is the instrument that is being used for measuring the electric current in any circuit? The instrument used is ammeter, and it is always connected in series. The symbol of ammeter we all know, it is encircled A, right? I have drawn it over here like this. The instrument used is ammeter, and it is always connected in series combination. Ammeter is connected in series combination like this. This is, suppose any resistor R, any component having the resistance, and ammeter is connected in series. It can be positive, it can be negative, we should write down. Okay, now next comes electric potential. Electric potential and electric potential difference, there are two terms. A little bit of difference is there in these two terms. Okay, now what is electric potential? It is related with the amount of work done in moving the charge, a unit charge, from infinity to a point in the electric field. Okay, suppose this is one electric field area, and from infinity means from outside this electric field area somewhere far away, if any amount of charge, if a unit charge, a unit positive charge is being brought into this electric field area, then whatever amount of work has to be done, that is given as electric potential at that point in that electric field. Okay, now this can be represented in the form of formula as V is equals to W divided by Q, right? SI unit is, we all know, that is volt. Capital V is the representation. According to this, SI unit becomes joules per coulomb, because work done has SI unit joules and charge is measured in coulomb, right? So this will be, according to this, joules per coulomb can be written as SI unit of electric potential, but Alexandro Volta gave this unit, that is volt. Okay, now how to define 1 volt, how to define the unit of electric potential or electric potential difference. This is what, if we define 1 volt according to this formula, then we can define the unit. This is how we can define the unit. Now what is electric potential difference? I have defined over here electric potential, and electric potential difference is the difference, potential difference between the 2 points in that electric field or in any conductor, we can say. So electric potential difference is nothing but the amount of work done in moving a unit charge from one point to another point in a conductor. Suppose this is a conductor, so from one point to another point in a conductor, if any charge is moving, then amount of work done is given by that electric potential difference. Okay, so if the charge is 1 coulomb, that is the definition, right? Now how to define 1 volt? In a similar manner as we have defined 1 ampere, according to this formula we can define 1 volt. 1 volt potential difference, the amount of work done is 1 joule in moving the 1 coulomb of charge from one point to another point. So it is a potential difference between 2 points in a current carrying conductor when 1 joule of work is done to move a charge of 1 coulomb from one point to another, right? So what is the instrument? Instrument, we all know, it is voltmeter, and it is always connected in parallel combination. It is always connected in parallel combination to any resistor R, like this. Between the 2 points across the resistor, it is always connected. Okay, so for a potential difference, we can write down the formula as VA minus VB is equal to W divided by Q. This is how we can write down. Next comes electric circuit. Electric circuit, how to draw electric circuit, that we have learned in the classes also, and how to define it. It is nothing but a closed path which has to be a continuous path, and there should not be any breakage, any break point, any discontinuity over there when the electric current is flowing. So it is a closed and continuous path through which an electric current flows, right? This is an example of any simple electric circuit. This is a key, we know. This is a battery of 2 cells, and the current direction is from positive terminal towards the negative terminal. And this is the resistor R, and across the resistor I have attached a voltmeter to measure electric potential difference, and in the series combination I have attached ammeter, okay, to measure the total current flowing in the circuit or flowing through the resistance R or resistor R. Then the direction of electrons over here, the direction of electrons is from negative terminal of a battery towards the positive terminal of a battery. As we know that at the negative terminal of the battery, the number of electrons are more as compared to the number of electrons present at the positive terminal of the battery. So from the higher number of electron side towards the lower number of electron side, the electrons will move. This is the concept based on the diffusion process, that is, from higher concentration towards the lower concentration, the object or particles will move. Here the particles are electron. Higher concentration of electrons are present at the negative terminal, that is why it is called negative terminal of the battery. And towards the lower concentration, they will move. Okay, so less number of electrons over here and more number of electrons are present over here, this in the battery or a cell. That is why electrons move from this side to this side. So electron direction is this one, and current direction is opposite to that. Even then, one must be thinking that electrons are moving from negative towards the positive direction, and current direction we always consider from positive towards the negative direction. Why it is so? It is there is nothing technical concept or topic present over here, but it is a convention that is being made long back when electricity was discovered. Okay, the convention was that current direction we will always consider from positive terminal of the battery towards the negative terminal of the battery. Convention means it was a rule, so it was the convention was being made so at that time, and that convention is being followed till now. Okay, uh, so the current direction is taken from positive towards the negative. There is no particular logic that why electrons are moving this side and current is taken this side. Current has been decided in long back because of the convention only. Okay, and that is why it is known as sometimes conventional current also. This current is known as conventional current. So conventional current is a term given to this current value whenever in any electric circuit it flows. So it is not a new term, it is not different from electric current. Okay, it is just a name given to the current which is flowing in any conducting wire that we are using. Okay, so convention means a rule that was being followed at the time of discovery of electricity. Okay, and according to that rule, according to that convention, the direction of current was from positive towards the negative, right? So that is why it is known as sometimes conventional current. In many books you or in many questions you can find this name, conventional current, right? Now, circuit diagram. How would we draw the circuit diagram? Circuit diagrams can be drawn using different symbols, which are also known as conventional symbols. Conventional symbols given in your book, okay, NCRT book, and it is also known as schematic diagram. Schematic diagram. So in some questions, maybe probably you will uh, get this word, you will experience that there are many terms which are related to each other, the circuit diagram or schematic diagram. Okay, so it is being used as one another, right? Now different symbols they are given. For the resistor we are using this symbol, for the cell we are using this symbol, for a battery we are using this kind of symbol, battery of 2 cells, battery of 3 cells, this the symbol for battery. For a meter we have seen already this, for voltmeter we have seen already this, for a variable resistor like this, for a rheostat like this. These are the symbols, various symbols that are given, okay. And for the wire joint, this is the kind of the symbol, and for the overlapping of the wire, that is the symbol like this for overlapping of the wire. So these are, there are many symbols. The key is like this is a closed key, this is open key. Sometimes key or switch can be drawn like this is an open switch, this is a closed switch, right? So these are the basic symbols that we should know. Now here I have drawn this one open circuit and one closed circuit. You can see open circuit means when the in a complete circuit, this is a simple circuit I have drawn, or in any circuit when we are using key, then if the key is open, the key is open, then it will be called as open circuit. And if the key is closed, then it will be called as closed circuit. The complete circuit will be called as closed circuit. Okay, so in this situation, when the key is closed, that means circuit is in on situation, or the switch we will call it as a switch is on. And in this case the switch is off basically, because the key is open, right? This we need to remember. Don't make a confusion over here, right? Next comes the very important topic, that is our Ohm's law. Ohm's law is giving us the relation between potential difference and the current which is flowing in any conductor. Okay, potential difference is V and current is I, that we have revised just now. So what is V? Electric potential difference across a conductor, and what is I? Electric current flowing in that conductor. These are directly proportional to each other according to Ohm's law. So it states that potential difference V across the ends of a conductor in an electric circuit is directly proportional to the current I flowing through it, provided its temperature remains constant or same. So this is a condition, this is very important condition, that temperature should remain constant, right? And this is important, that potential difference is directly proportional to the current, or we can say current is directly proportional to the potential difference. So if we simplify it according to mathematics, V upon I will be equals to constant, and this constant we are having a particular value, that is R, which is named as resistance of that conductor in which the current is flowing, right? So the formula for Ohm's law becomes V is equals to I into R, and this resistance R is always constant for any particular material or any particular component at a given temperature, right? Now how will we define this resistance? This resistance is nothing but obstructions in the flow of the electrons, okay? Or how will we define this? Let's see. It is property of a conductor to resist the flow of charges through it. Now, how the resistance comes into picture practically? Practically, what will happen in the conducting material? Suppose this is a wire. Suppose this is a wire. I will draw over here. Let's take some different page. Suppose this is a wire, conducting wire. Okay, and in this conducting wire there are many electrons which are free to move, and they are moving, suppose, in this direction when the potential difference V is applied across the ends of the wire and the current is flowing. What is the direction of current? It will be opposite to the direction of electrons, right? When the electrons are moving, then what happens? They may collide with other electrons, okay, or they may experience some attraction towards the nucleus of the atom, because nucleus of the atom, it is positively charged. Okay, nucleus is having protons as well as neutrons. So sometimes what happens, these electrons, when moving from one atom to another atom, then they may get attracted towards the nucleus sometimes, because it is positively charged nucleus. So what is this? These are the two concepts from where we can say that electrons may collide with each other, or electrons may get attracted towards any nucleus of the atom. Because of these two kind of obstacles, okay, we can say that it resists. Okay, and the flow of charges has been resisted because of maybe these two reasons. And when these are resisted, the combined effect, we can have it as resistance. The term or the physical quantity defines these two things as resistance. Okay, now what is the unit of resistance? Unit of resistance was ohm, because it was defined by Ohm's law. Okay, so unit was ohm. Now how will we define 1 ohm? Similar to the previous two cases, as 1 volt and 1 ampere, we can define 1 ohm according to this formula, this basic formula. So R is equal to basically V upon I. Okay, from here R is equal to V upon I. So if V is 1 volt, I is 1 ampere, then R becomes 1 ohm. Okay, so this is how we can write. 1 ohm is the resistance of a conductor if potential difference across its two ends is 1 volt and current through it is 1 ampere. Okay, so 1 ohm equals to 1 volt divided by 1 ampere. From here we can say that when potential difference is applied, a fixed potential difference is applied, when V is fixed, then we can say that R is inversely proportional to I. Okay, so, or we can say I is inversely proportional to R. Okay, that means if R is doubled, resistance is doubled, the current will be halved. More and more resistance, the less and less current. Theoretically also it is correct. More and more obstacles in the path of electrons, so it will be difficult to flow, and then the current value will be less, right? So this is the concept that we need to remember. Now there is a concept of variable resistance given in your books. It is nothing but a component which is used to regulate the current without changing the voltage source, is called variable resistance. Fine.